Hi there, welcome to this video where you would get a quick start for the JUnit framework. In this video, we are going to talk about what is unit testing, what is JUnit, and then we would move into the different annotations which are related to JUnit. At test, we'll also talk about at before, at after, at before class, at after class, and we'll take a quick look at the basic assert methods. At the end of this specific video, we'll also look at exceptions, test suite, and a quick look at the best practices with JUnit. Typical Java projects are made up of number of classes. So here we have a client BOIMPL, different currencies exception, and a lot of classes. A typical Java application contains more than 1,000 of these kind of classes. A unit test is typically used to test the code under specific unit. So the unit of code can be a method, a class, maybe a set of methods or a set of classes. Typically, in the best kind of unit test, you would have unit test testing specific important methods. So for example, in this client BOIMPL that you are looking at, there's a method called getClientProductSum. Let's say this method is called from controller and the details from here are shown on the screen. And let's say this is in the 15th screen of the application. So if you make a logic change here, let's say I'm making a small change in here. So if I have to really test that, then in the typical flow, if I don't have unit test to test it, I would need to actually create a jar, create a var probably, deploy it into the server, navigate to the 11th or 12th screen and check whether the sum which is displayed there is proper or not. That's a lot of effort. And the other thing is also this kind of a testing effort is very manual. Unit testing is where I take this method and I directly write tests for this particular method. So I write tests for this specific method, passing in all the kind of input variations that are possible and check whether the output that the method is giving back is as per expectations. This is one of the tests that we wrote for the clientProductSum method. Don't really worry about the code in here. We'll look at what's the details about the JUnit test a little later. But you'd be able to see that I can do a right click, run as JUnit test, and you'd be seeing that the test would run and it says a green bar. So this is something called a JUnit green bar, and you are saying that the tests, all tests have succeeded. The same test, if there is, let's say, some logic error in this specific client BOIMPL, let's just introduce an let's just say this was not working fine and I'm just not doing one of these steps. So here you can see that it expects a different currencies exception in a specific scenario. So what I'll do is I'll not throw the currencies exception in that scenario. So I'm making a change in code just to see what would happen. Now I can go ahead and do a right click, run. Okay, you can see that the test is failing. So this test says expected exception, different currencies exception. So basically what we are doing in here is basically testing all the scenarios that are possible for this specific method. As soon as I make a change in this method which causes any of the tests to break, you can see that the test starts failing. This is what is called unit testing. In unit testing, we try and test a specific method, passing in the input parameters that are needed for that specific method. With unit testing, our focus is on ensuring that a specific unit of code, it can be a method, a set of methods, classes. I mean, there are varied range of variations that are present, but a specific unit is working as expected. In most of the projects, I think one of the best practices with unit testing is to test the public methods of a specific class. So this is a public method in client BOIMPL. I'm writing unit test for this specific test. I'm writing unit test for this specific method. So now, what is JUnit? JUnit is basically a Java framework for unit testing. That's it. So JUnit is the most popular Java framework for unit testing. So JUnit has a lot of different annotations which would be helping us to write unit tests. So you have annotations called atTest, you would have annotations called assert, you would have like atTest expecting an exception, and a lot of variations like this. So these are the different things that are present. We'll discuss about all these annotations and we'll take them step by step a little later in this specific video. But this is just to show you what are the different parts of your JUnit test. We looked at the first two things, unit testing, and we looked at what is JUnit. So now let's start writing our first unit test. The way I can create a new project in Eclipse is by saying file, new, and say other. I just say new project. and I'll choose Java project, click next. I can actually choose to create a Maven project, but I don't want to really confuse you with Maven. So I just create a simple Java project. I'll call it JUnit Quick Start. I'll leave all the rest of the stuff at default and click next. Okay, one of the important things with JUnit is one of the things which we would do is we would want to maintain our test code and the source code separately. So your code which goes to production, we would want to maintain it separately, and the code which you write to write unit tests, you'd want to have separately. So what I'll do is I'll delete this particular thing. So I'll say right click and say remove from build path, and I would do right click and say new source folder. And this is Maven conventions that I'm following. So source main Java is typically where you put all your source code. It's source src main Java, src /main /Java, and you can say finish. Now this is one of the source folders, and next I'm going to add in another source folder. So I'll just need to go and say right click and say new source folder, and the next one I would say source test Java, source main Java, source test Java. Those would be the two things. We'll put our source code in source main Java, and we'll put our test code in source test Java. So I'll ask it to use the Java perspective because that's cool. Now you'd see that the JUnit Quick Start project is created with two folders, source main Java, source test Java. So that's the typical structure we use for creating unit tests. And I would want to start creating our first unit test. So now we have the Java project ready. I can go ahead and create, right click, new, and choose other and say JUnit. So I'm saying create a new JUnit test case, and I'm going to new JUnit for test, and I would give some package. So let's say com.junit.quickstart, and the name of this specific test that we are going to. So what we'll do in this specific test is actually we would want to test this string class. So string class is already part of the Java API. We'll write tests for the string class. So I'll call this string test. So string test, and you don't need to worry about rest of this stuff, and say finish. So one of the things it's asking is, Eclipse is saying, you said you want to write a JUnit, but JUnit library is not on the build path. Okay, you can add it in now. So I'm saying, yes, go ahead, please. Okay, now the test is created, and you can see that there is a small piece of code which is generated. Let's not worry about it right now. All that we'll do is, for starting off, right click, run as JUnit test. Aha, this is failing. That's good, because this is actually using one of the assert methods, which we'll be talking about a little later. This is using one of the assert methods, which is fail, and it's saying not yet implemented. So the test is not yet written. That's the reason why it's failing. So what I'll do now is actually remove this specific thing. So, and say right click, run as JUnit test. Aha, this is your first green bar. So there you go. That's your first successful JUnit. The first successful JUnit that you wrote has no code in it. Isn't it some magic? Like, so to make a JUnit successful, if you don't write code in it, then it's successful. Isn't it funny? Okay, let's get serious. One of the first things that we would talk about is the add test annotation. So I can have multiple methods in here. So public void test something, or public void any kind of a method that you can want to write. So the way you tell the JUnit framework that this is a unit test is by putting the annotation add test. So if I do a right click, run as JUnit on this, you'd see that only the first test would be run. So you can see here on the left hand side that only the first test is running. This is not really running. If I want to write a test in this method also, what I would need to do? I would need to put add test annotation on that as well. So now you'd see that if I do a right click, run as JUnit test, what would happen? You would now have two tests, test and test something. You could have actually, for simply easily naming, could have called it test 1, test 2, and I can say run, and you'd see now that test 1 and test 2 have run, and they have run successfully. So that's your first thing. Add test annotation is basically your way of saying, okay, my test is here. So this is the method containing a unit test. That's basically what you would signify by using the add test annotation. So now we have understood what is unit testing. We know what is JUnit. It's a unit testing framework for Java. And we started with our add test annotation, which is basically an annotation which you put on top of your test to signify that this is a test method. Next, we are trying to understand the principle no failure is success. We already got a quick preview of that. Both these tests have succeeded. So both these tests are showing the green bar. Okay. So why? Because in JUnit test, absence of failures. So JUnit tests are basically tests with a lot of checks. So you can write a lot of checks saying, check this, check that, check this, check that. And if none of the checks fail, then the test is a success. So these checks, we would call them as asserts. So we will do a lot of asserts in your JUnit test. So we would assert if the output of this method is this. You would assert if the output of this method is something else. So if I'm passing a specific parameter, whether I'm getting that output, we assert that. So if all the asserts in the test are successful, then the test is successful. If none of the tests, like if any of the asserts in a specific test do not match, then the test would fail. This test actually has how many asserts? We have not written even a single line of code. So this test has 0 asserts. And a test with 0 asserts will always succeed unless there is an exception thrown from there. But what we have here is an empty method, and because nothing is failing, it's considered to be success. So that's something which you need to always remember when it comes to JUnit framework or any unit testing framework. Absence of failures is considered to be a success. Next, let's move quickly on to the basic assert methods. I'll do a little bit of cleanup. I'll remove we have a test. So we would want to learn about the assertEquals method. I'll call this the test to learn assertEquals. So I'll say test to learn assertEquals. So what is assertEquals? So let's do a simple example. So I'm calling assertEquals and passing 2 numbers to it. So I'm saying assertEquals 2, 3. Okay. Okay. I need to import it. Control spacebar. Just go near assertEquals and press control spacebar. Eclipse should bring up a list of things. So I'll just say assertEquals 2, 3. So what you'd see actually at that point, assertEquals is it does a static import. So actually assertEquals is a static method in the JUnit assert class. So in the assert class, there is a assertEquals method. What we are doing is we are doing a static import so that we don't need to say assert.assertEquals. So we just say assertEquals and 2, 3. If we didn't use the static import and normally imported JUnit assert, then you would need to actually do something like assert.assertEquals and then import assertEquals in the normal way. So you can do it both ways. I really prefer the static import way, so I'll leave it with the static import. So static import is clearer because I know it's coming from JUnit assert class. So assertEquals 2, 3. What would happen? Let's see. Run as JUnit test. Expected 2 but was 3. So it failed and it says expected 2 but was 3. Okay. Now let's see. I'm passing in 3. Let's see if what would happen. 3, 3. Aha, green bar. The test succeeded. So 3, 3 was success. So it succeeded. But when we sent in 2, 3, what we saw that this failed with the message expected 2 but was 3. Let's do another combination. So let's say assertEquals 3, 2. What would happen? Try and guess. Expected 3 but was 2. Expected 3 but was 2. Okay. So there are the different combinations of your assertEquals. AssertEquals basically is a method to check the expected output versus the actual output. So in a JUnit, you want to test a method, right? So I want to test a specific method. So I'll call the method. So basically I'll call the method and the output of that is what we call as the actual output. So actual output is whatever output you get when you call the method under test. We call it the method under test because that's the test that's the method which we are testing right now. So actual output is the output from the method under the test, and this actual output we want to compare against the expected output. So for example, let's say actual output is math.min. So I'm calling the min function on the math class. I'll pass two numbers 5, 10, which is the minimum of this. So the expected output is 5. So if the math.min class is working properly, it should return 5. If math.min returns any other output, then we want the test to fail. So we want to match the actual output from this method with the expected output, and that's what the assertEquals method does. And if the output does not match, if the output of these does not match, then it would start failing. You can see it here. When I called assertEquals 3, 2, the output, like these two variables did not match, so it started failing the test. On the left hand side, so whatever is in the left hand side, typically in the assertEquals methods, whatever is on the left hand side is called expected output. This is more of a convention in how the JUnit framework does it. So on the left hand side is always the expected output, and on the right hand side is your actual output. Standing in front of the computer, my left hand side is expected output and the right side is the actual output. So this is expected. You can see I'm expecting 3 but was 2. So when I'm writing an assertEquals, let's say I'm the programmer for math.min method. So you are the programmer developing the math.min method, and you want to check whether the math.min method is working for a specific thing. So I'd say int my actual output. This is the actual output, right? What's the actual output? The actual output is math.min 5, 10. What is the expected output? The expected output when math.min 5, 10, if it's properly working, then it should return back 5. So now I would use the assertEquals method to check the expected output versus the actual output. And now let's run this. Awesome. It succeeds. Let's say I'm changing the expected output. So I'm making the expected output as 6. Aha, the test fails. The test failed because the expected output did not match the actual output. Now, I can write a similar test for, let's say, a string thing as well. So let's just quickly do something on the string as well. So for strings, the actual output and the expected output would be strings, right? So I just change the case. So actual output is, let's say I want to do an uppercase on a specific string. So let's say a string value is equal to A, B, C, D, E, F, G, H. And what I want to do is uppercase on this. So value dot uppercase to uppercase is the actual output, and the expected output would be A, B, C, D, E, F, G, H. So now this test would actually, this test to check string uppercase. And now I can run this test, right click, run as JUnit test, your favorite stuff until now, I guess. So if I go ahead and do that, you'd see that the test would succeed. Again, if I actually change this and run this test to check string uppercase, you'd see that the test would start failing. And one of the important things about the JUnit asserts, the JUnit framework, is it clearly points out what's changing. So it's saying, I'm expecting A, B, C, D, E, F, G, but it was A, B, C, D, E, F, G, H. And also the changed part is highlighted very clearly. It's saying H is missing. That's one of the nice things about JUnit frameworks. It clearly points out what's the difference between an expected output and the actual output. We already looked at assertEquals methods for numbers. These are assertEqual methods for strings. And as we discussed earlier, there are assertEqual methods for other types as well. One of the other methods that is present in JUnit is, if let's say the code gets to a certain point and you would want to fail the test, there is something called fail method as well. So if you do a org JUnit assert fail, so as soon as that method is executed, the test would fail. So there might be situations where you would expect an exception to be thrown by the method before. In that kind of scenario, you want to fail the test. When it gets there, then you can use the fail method. Sometimes in test methods, you'd want to do something before each test. So that kind of a logic can be put in at before kind of an annotation. So if you do a control 1 or a command 1, you can import org JUnit before, and this, I mean, the name of the method is not really important. The annotation before is the one which is important. So I'm just doing a sysout here. I mean, I just don't really want to do a lot of logic here. So if you want to do, let's say, a setup for a test class, then you can like set up for a test method. You can do that in an add before. So like I'll just say sys before, like sysout before, and run this. You'd see before printed twice, but it's not really clear. So what I'll do is actually like yeah, I'll just, in each of the tests I'll print something. So sysout, let's say test1, and in the next one I'll say test, and I'll now run it again. Okay, now you see that there is before test1, before test2. So whatever test you have with this test was failing because okay, now both tests would succeed. I mean, I hate to see a red bar when I'm explaining something. So let's fix it. Okay, is it still red? Yep, asserted 6 but 5. Oh, this is the one which is failing as well. So let's fix that as well. So this would have a green bar, hopefully now, green bar. And now you see before test1, before test2. So the before annotation, whichever method you have a before annotation on, it would be executed before every test method. And similar to that, similar to the before, you have an after as well. So you can say at after. So I have to obviously rename the method. So I don't really need to call this after. I can call it after anything. I mean, it doesn't really matter. So the name of the method does not matter. The most important thing is the at after annotation. If you want to do any cleanup after every method, then you can do that in the at before and at after, I mean, in the at after annotation. Now you'd see, okay, let's go ahead and save it. So before test1, before, oops, I made a mistake again. So it should be, I should call this after, so that we can see clearly what the message is. Run JUnit test, and you'd see now before test1, after, before test1, test2, after. So this is when you have to do something specific to every test method. So before and after are run before every test method in the test. So if I have 5 tests in the test class, then before would run 5 times, and at after method would also run 5 times. The opposite for that are the before class, not the opposite, the, you can say parallel. So I'll call this before class. I'll also change everything to before class. So now I'm changing this to before class and this to after class. So we looked at before method, which was run before every method. So if I had 5 tests, it would have run 5 times. Now we are looking at before class, which is only run once per class. One of the important things about before class is that the method should be static. One of the important things that we learned in Java programming is anything that is at class level should be static. So static objects, static methods are class level things. Similar to that, before class is a class level thing because it's run once every only once for every test class. So I would need to use the static keyword. So public static void, and the same with the after class method, public static void after anything. And now you'd see, so that this is run before the class, the tests are run, and then the after class. So typically in the before class and the after class methods, you would initialize something which is really expensive, something which you don't want to do with every test. You can do that in at before class and at after class. For example, if you are, let's say, connecting to setting up an embedded database, or you are connecting to some expensive system, then you would actually do those kind of things in at before class and at after class. In methods which are annotated with at before class and at after class. So we have started with unit testing, JUnit, at test annotation. We saw that no failure is success, and we looked at a couple of basic assert methods, assertEquals methods. And next we started looking at before and at after, and now we also looked at before class and at after class. So let's say I want to test for exception. So let's say a specific method is expected to throw an exception. So how do we test for it? So for example, I'll just take this method where the value instead of A, B, C, D, E, F, G, H is null. So what would happen? What would this test case do? So I'll create a new test. So I'll just copy this test out and say test to check string uppercase null pointer. Because if I have the value of something as null, what would happen when the method is called? What would happen? Think about it. So this would throw an exception. Run as JUnit test. So you can see that this actually is throwing a null pointer exception. So which line is throwing null pointer exception? So this is a proper test case. If the value is null, the to uppercase method, like you're calling on like a null object, so it should throw an exception. So if you want to test for exceptions, so if I want to check whether the exception is thrown prop or not, then there's a thing as well. At test exception is equal to, sorry, it should be expected is equal to, you can say null pointer exception dot class. And now you would see when you run this test again, this test succeeded. So you can see that the test succeeded. So that's how you check for exception. So if you are expecting, so if it's a valid scenario, I mean, in a lot of situations, throwing exceptions is valid, right? Because like when you don't know what to do, if some illegal argument is passed, then the method would throw an illegal argument exception. When some method is called on null, it's throwing null pointer exception. That's expected behavior. And in those kind of scenarios, if you want to test that the expected behavior is an exception, you can use the at test expected is equal to null pointer exception kind of a thing. The next thing we want to talk about is test suits. In this specific class, we just have one unit test, string test. So let's say I'm just duplicating the test a few times. So let's say I want string 1 test, string 2 test, and I would want to be able to run these two tests together. One of the ways you can do that is do a right click, run as, and then configure something so that you can run those tests out. So on a single class, it's very easy. Right click, run as JUnit test would come in here, so you can do that. However, let's say if I want to run just these two tests together in certain situations, you can create something called a suit. How do you create a suit? So file, new, other. So under JUnit, you'd see JUnit test suit. So just a next. And you can say which test classes you would want to include in the suit. So I'm including string 1 test and string 2 test, and say finish. So you'd see that there is a suit called all test which is created, where the suit classes are mentioned in here. So you can actually modify this. So whichever test class you want to run along with the suit, you can actually specify them in here. This is useful in running a group of tests. So now when I run this as a JUnit test, you can see that only the tests in string 1 tests. So you can see that only string 1 test and string 2 tests are run, and the other string test is not really run. So this is a suit is a useful way to group your tests together. So let's say some of the tests you are running are slow and you don't want to run them always. So you can exclude them and create a suit with the other methods, and you can start using the suit to run the faster tests. And you can run all tests once in a while. Maybe you can run this suit much more often because the tests in the suit run much faster. The last thing which we want to look in this specific quick start video is the best practices around JUnit. The code example which we'll be using now is actually present in the GitHub repository, github.com/in28minutes/JUnit in 28 minutes. This is actually a complete course on JUnit. I mean, it's just almost a 2 hours course. I mean, the video which we are watching right now is a kind of a quick start kind of a thing. If you're really interested in learning JUnit fully, this would be a GitHub repository that you can go to, and you can actually learn JUnit in much more detail. So we are taking the example from here to illustrate the best practices. So if you import that particular project, what you'd see is two tests, client BO refactored and client BO test. So client BO test and client BO test refactored. So client BO test refactored is one of the like tests which follows all the best practices, and client BO test is something which does not follow the best practices. So what I'll do is actually like put this method on the screen right now. So you can actually pause the video here and try to understand what this method is doing, and like probably pause for 15-20 seconds and see what you'll be able to understand by looking at that method. And next, I would recommend you to pause with this method in the screen and try to understand what you would be able to understand. If you spend some time looking at both the methods, you'd see that the second test is very well written and easy to understand because it's well named. So you can see that this is testing the client product sum with all products having the same currency. So currency is euro, and you can see that the expected and the amounts are 5, 6, and the sum is 11. So you can see that actually like I am removing all the unnecessary things from this test. So if you look at the client BO test, there are a lot of values in here. So there is 100, product 15, bank guarantee, 120, product 20, bank guarantee, which is not really important for this specific test. So these make the test very difficult to understand. In this test, we are only highlighting the important values. All the other stuff, what we are doing, we created a method called create product list with amounts, and we moved the logic to create the product down there. So what happens there is we are highlighting important things in this specific test. So we whenever we want to write a unit test, one of the important things that you need to focus on is when you look at the test, it should be understandable in less than 15 seconds. I mean, that's kind of the guideline I have. So when I read the test, I should be able to clearly understand what I'm testing in that particular test. And one of the important things for that is to name your method properly and to highlight only the important values in your test. All the values that are not important, send it to other utility methods and put it down there. So if the method only highlights, if your test method only highlights the important things in your test, then that's a very, very good start. The other important thing that you need to actually focus on is any test involves a setup part, the execution part, and the check. So this is the setup part, this is the execution part, and this is the test part. So in a test, it's very good if you can clearly separate them out. So you have a setup, you have the execution, and you have the check. So these three parts should be clearly separated. The other best practice is also that you should have one assert in a particular test. So you should not be testing 100 things in the same test. You should have different tests for different scenarios. So here, if you look at it, when I have two different currencies being passed, then I'm expecting an exception to be thrown. So I'm having a separate method to test that. So test client product sum, different currencies, throw exception. So you can see this and you'll be able to understand what this particular test does. And you can see here public void test client product sum, no products. So I'm testing the scenario when there are no products present. And when there are no products, then this expected sum is 0. So you can see that all the things are easily readable. So that's one of the most important characteristics of good tests. So what the best practices as far as unit testing are concerned is number one, make sure that your tests are readable. Number two, make sure that your tests are independent of anything external. Your test should only fail when something in your business logic is wrong. It should not fail if something in the database is wrong or something in interface is wrong or those kind of stuff. In those kind of scenarios, you have to mock out the interface or mock out the database so that your tests are independent of anything external. Your test should fail only when your code has a bug. That's a very, very important thing. So if you follow these two best practices, then you're doing really, really well. Okay, we now are almost at the end of the JUnit Quick Start. The objective that we had when we created the JUnit Quick Start is to just give you a flavor of the whole thing. I'm sure there were a few places where we ran very fast, faster than we would be in a ideal scenario. But the idea was to give a very, very quick start for JUnit framework. If you're really interested in understanding JUnit fully, I would recommend you to do our 2-hour course on JUnit, or even better, one of the important concepts related to unit testing is mocking. And I would recommend you to do the course on Mockito, which has really great reviews. So there you go. So that's the end of this JUnit Quick Start video. Until the next time, bye-bye.